Hello and welcome to this, my video on factorizing algebraic expressions. Could it get any more exciting than this? Probably if we were somewhere else not watching math videos. I know, I feel your pain. I'm recording them in a room on my own. I am talking to myself. The dog's even given up listening to me. Anyway, my name's Darren from Maths Guru. Thank you very much for joining me. Hopefully this video will be useful. If you can do me the smallest of honor and going to YouTube to Maffs Guru. What do you mean you don't know how to spell it? It's down here. Look, M-A-F-F Guru. And just clicking subscribe, I would be deeply grateful. So very few people watch math videos, and I get to a point where I go, now, why am I doing this? All right. So every time someone subscribes, get a little bit like, oh, someone's watched a video. That would do me the greatest of honors. Now, what do I do normally? Well, I would normally talk over the learning objectives, but come on, guys, you can read what's behind me. And talking about what's behind me, you can actually download these notes from mathsguru.com. All right, so basically everything I write on, I upload to my website with exam questions and sort of notes, and these videos all sequenced against Cambridge, and thank you very much, Cambridge, for letting me use your examples. But basically, this all there for you. So should we get started? Now, I normally recap past learning, and if you've just watched the previous video, then don't worry about it because you should already know. But we've so far dealt with some of the more interesting stuff here. How to multiply out a set of binomial products. So by that, I mean x plus 2, x plus 3. So whenever I see anything like that now, I know how to multiply it out. I can either use my grid method or I can use my FOIL, but multiplying these out and then simplifying them is huge in Year 9 course and like massive in Year 10. So it's a skill that you've really got to get to understand, which is what this video is for, isn't it? So that was the first part. Then we came up and said, well, what happens if we had x plus 2? X minus 2. Are there shortcuts? Is there any way that we can sort of look at that and go, aha, I know how to do it? And we worked out that that gave me the difference of perfect squares, because when I multiplied that out, it gave me x squared minus 4. And again, we realized that that was a squared term, and that 4 in that situation could be written as x squared minus 2 squared, and that was great. All right, it made life so much easier for me. In this situation here, though, we ended up with x squared plus 5x plus 6. And you're going to go, sheesh, you did that quick. I'm 147 years old. I should hope I can do these quickly in my head. And there are shortcuts to doing these, but I leave that to you for the moment to sort of work out as you get there. Because the shortcuts go horribly wrong if you don't know what you're doing. All right, so we got there. But the question is there a way to go from here to here? Is there a way to go from here or here back to this? Well, as it turns out, yes, and it's a what is it called? A mathematical area called factorization. And again, it is massive in the Year 9 course and like super massive in the Year 10 course. So hopefully you are going to sort of follow along. But when we factorize, and we'll start with some nice basic ones. Now, I always call these type 1 examples. All right, so later on in next videos, I'll be asking you to try and identify type 1, type 2, and type 3 sort of questions, because that's going to decide how you factorize it. And so we're going to say type 1 questions at the moment are ones that basically have, generally speaking, sometimes have 2 terms in it. And you're going to say, what's a term? And I'm going to say 2x and 10, x squared and 5x, 2x squared and 10x. Now, when we factorize, we are trying to take out the highest thing we can divide both of those terms by. The highest possible thing we can divide both terms by. So for example, if I look at 2x plus 10, yeah, now the first thing I always do is I look at the numbers first and I say, right, what is the highest common factor of 2 and 10? Well, in that situation, I'm going to say it is 2. Then I look at the letters and I say, do the terms share any common letters? Well, we notice in here that's got an X. We notice that that has no letter terms, in which case then we have no letter terms. So what I now do is I do a set of brackets. And when I am taking out the highest common factor, I am effectively dividing by what my highest common factor is. And if you are like freaking awesome at doing this stuff, you're going to know that that 2 and that 2 there can cancel and it becomes 1 on 1. And we know that 2's go into 10 5 times and 2 goes into there once. So what we get left with is 1 times x, which is just x. And so that's going to go in there. And what we get left with here is 10 divided by 2 is 5, or plus 5. And there we go. And that, believe it or not, is factorized. And you're going to say, because remember, if I now undo the process, what would 2 times x give me? Oh, it give me 2x. And what would 2 times plus 5 give me? Plus 10. Aha! So basically, factorization is just dividing everything by a highest common factor, putting that highest common factor outside the set of brackets. So because we decided the highest common factor was 2, we put it outside the set of brackets, didn't we? And then when I divided everything, I effectively put what was left. So there was the 1x and then plus 5. All right, let's look at another one. Right, and again, this takes practice. If you're sitting there now going, what is he talking about? Well, probably I don't know myself, but that's just a little bit hurtful. We'll leave it there. All right, but the point of it is, just you have got to do probably like 100 examples of this, and it'll get into your head, and you will never forget it. And you're going to go 100 examples? Hey, maybe 20. 20 examples passes from your long-term memory into your short-term memory into your long-term memory. So here we go. We got x squared plus 5x. Now, what is my highest common factor? Well, I always look at the numbers first. What's in front of the x squared? Oh, there's no number. Yeah, there is. It's a 1. All right. And what's in front of the x? It's 5. Right. So what's the highest common factor of 1 and 5? Well, it's 1. So I'm not going to write that because that's a bit pointless. Now I'm going to look at my letters. I've got an x squared and I've got an x. Now this is where the brain tends to get a bit freaky or a bit like messed up. X squared is the same as x times x. So what I can see here is I've got 1x there and 1x there. So the highest common factor of this must be x. Or I can divide each of these terms by x. So I'm going to divide that by x. I'm going to divide that by x. I'm going to do my set of brackets. I'm going to go equals. And I'm going to write an x outside my brackets because that is my highest common factor. Whatever I'm dividing by here goes outside my bracket. So now we can do some cancelling out. So an x on the bottom cancels with 1x on the top. An x on the bottom cancels with 1x on the top. And what do we now get left with? Well, we get x times 1, which must give me x. And then plus, what do we got left here? 5 times 1, which is 5. And again, I always double check by multiplying out my brackets just to make sure that it's right. Is x times x squared? It is. X times plus 5 is plus 5x. Life is good. What about the next one then? Oh, I'm running out of room. So let's move this one over a little bit. Let's move that over all the way over here above my little logo. And then what do we got here? We got 2x squared plus 10x. And again, these examples can all be downloaded. Right, so let's look. Numbers first. I've got 2 and a 10. Right, what's my highest common factor of 2 and 10? It's 2. So first thing I'm going to do is I'm going to write it down here. Let's do it here. 2. And then I've got to look at my letters because are there any letters that are common? Well, yes, I've got an x squared, which is x times x. And I've got an x here. So they share 1x. So in this situation, I have both a number and a letter as a common factor. Right, so let's see what we can do now. We're going to divide that by what was outside, which is 2x. I'm going to divide that by 2x. Now, again, the more you do of these, the better you get. I promise, I promise, I promise. When I was at school, I had no idea what was going on when we did this. All right, look at me now. I'm a maths teacher talking to himself in a room. Anyway, so 2 goes into there once and 2 goes into there once. Ka-ching. X goes into there once and x goes into there once, leaving me with just the x. 2 goes into there once, 2 goes into a 10 5 times. X goes into there once, x goes into there once as well. So let's see what I've got left. What I've got left on the top, well, I've got 1 times x on the top, which suggests therefore that that should be an x in there, plus what I've got on the top here, 5 times 1, which is 5. And then let us just check that what I've got actually works. 2x times x does give me 2x squared. 2x times plus 5 does in fact give me 10x. The world goes crazy, and these are what I call type 1 questions. Now again, they can get more complicated, they can ask you to do all sorts of stuff here, but let's determine the highest common factor. Let's go back a bit and let's see what we actually come up with here. So what is my highest common factor of 6a and 8b? All right, 6a and 8ab. I know I said 8b just there. 8ab, my brain is working faster than my mouth is. Right, so let's look at the numbers first. What's the highest thing that goes into 6 and 8? Well, it'd be 2. So I'm just going to write 2. My highest common factor is 2. Am I finished? No, look at the letters. I've got an A here and an AB there. What letter are they sharing? A. So my highest common factor in that situation would be 2a. What about the next one? I've got 3x squared and 6xy. Right, what's the highest common factor? Look at my numbers first. 3 and 6. 3. What is my highest common factor? I've got x squared. That's x times x. I've got an x times y there. They seem to share just one x. So in which case, my highest common factor there would be 3x. My goodness. What about 4x and 10xy? They seem to be fairly common now, don't they? 4 and 10. What's the highest common factor between 4 and 10? It would have to be 2. That's the highest number that goes into both of those. What about x and xy? Well, again, it would be x. And the last one, 5x squared and 15xy. Look at the numbers first. Highest common factor between 5 and 15 would be 5, because 5 goes into 5 and 5 goes into 15. And then what have we got left? We've got x squared, which is xx, and xy, which will just give me x. Wow. Now again, I keep saying this over and over again. Practice. Now, obviously, as I said here, factorizing is finding the highest common factor. Let's do some examples. We'll do more and more examples. The more I do, the more your brain will be like, ah, ka-ching. It'll be like a light bulb moment. So let's start with, what is it? 40 minus 16b. Now, this is a really easy one because we've only got the numbers to look at. What is the highest common factor of 40 and 16? So I'm going to write it is 8. And are there any letters that can be shared? Nope, because that doesn't have a B in it. That has a B in it. So it's just going to be 8. All right. So again, we're now going to be saying 40 divided by 8, 16b divided by 8. Well, we know 8's going into there once, and 8's going to there 5 times. 8 goes into there once. 8 goes into 16 twice. And so in which case, what do we got left on the top? We got 5 there minus 2b there, and ka-ching, we're done. And again, always just double check. Is 8 times 5 40? Yes. Is 8 times negative 2b minus 16b? It is. We can't have made a mistake. Ooh, minus 8x squared minus 12x. Now we start to throw a bit of a curveball in here because we've got minus signs. Right, so let's look at the numbers first. In this situation, we've got minus 8 and minus 12. What's the highest number that goes into minus 8 and minus 12? Yep, negative 4. So I'm going to write negative 4 here. Now we look at the letters. I've got x squared, which is xx, and I've got 1x here. So I've got 2 x's here and 1x here. So that means basically I've got an x. Now again, when I say 2 x's, I mean x times x. There are 2 x's multiplied together. Right, so let's now do some division. So we're going to divide by negative 4x. And we're going to divide that by negative 4x. Now again, this is where it's important to know that a positive and a negative become a positive, and a positive and a negative and a positive become a negative, he says, writing above his head. Here we go. So let's see what we've got to do. Let's do some cancelling out. Well, a negative and a negative become a positive, so they cancel out. 4 goes into there once, 4 goes into there twice. 1x on the bottom. I've got 2 x's on the top, so that leaves me just 1x. A negative and a negative become a positive. 4 into there goes once, 4 in there goes 3 times. X into there once, X into there once. Now again, this looks complicated, but again, I in my head do it a slightly different way, which I'll talk about in a different video. So now let's see. There's no negative signs anymore. So I've got the 2 times the x on the top. So there's my 2x. I've got a plus now, remember, because that minus and that minus cancelled out and made a plus, or they didn't cancel, they became a plus. So I've got plus 3 times 1. So it becomes plus 3. And again, let's just check. Is minus 4x times 2x negative 8x squared? It is. Is negative 4 times positive 3 negative 12? It is. The world goes crazy. All right, now the next 2 examples are exactly the same, so I'm going to leave those to you to have a go. But what I'll do is I'll try and write down the answers first to see whether you can get there first. So 28 minus 21a, highest common factor is going to be 7. So it's going to be 4 minus 3a. That's my answer. See whether you can actually do it by doing the division. And then I've got minus 9x squared minus 15x. Again, we're going to take out negative 3x in this one, and that's going to give me 3x plus 5. And again, stop the video, have a go back. All right. I think the important thing at the moment is trying to make sure that you can get this division stuff properly in your head. Yeah. Or backtrack it. If I'm really honest with you when I do these questions, as soon as I know that 8 goes into those, I put the 8 outside and then I go 8 times what gives me 40. It's got to be 5. 8 times what gives me minus 16b. It's got to be minus 2b. And again, as I get older, this is better. Now, factorization tricks people, particularly when we start writing gross things like this, because people suddenly go, oh no, it's got brackets in, I've got to multiply out the brackets. No, you don't multiply out the brackets. Factorization, let's go back to the previous question. If I had 2x plus 5xy, what's common? Well, I can't do any of the numbers, can I? Because nothing goes into 2 and 5 except 1, and we don't tend to write the 1. But we notice that we got an x and x the same. They are exactly the same. They are separated by a plus or a minus. So anything that was exactly the same, we can effectively divide out and factorize. Well, if we now look at this example here, if you look at 3 in brackets x plus y, plus x, and in brackets x plus y, can you see anything that looks exactly the same? Well, yes, we've got x plus y in brackets. So the brackets are really saying, treat me like one thing. So I've got 3 times one thing plus x times the same one thing. Well, hold on a moment. If they're the same, we can factorize them out. All right, so there's a lot of yabbering from me. Let's actually see what happens. So we've got 3 in brackets x plus y plus x in brackets x plus y. Right, so what do? Anything that is the same in the term, that is our highest common factor. So let's look at the numbers first. There's a 3 there, there's an x there. They're not numbers, they're not the same ones. The number 1's a letter, so I can't factorize out. But I've noticed I've got an x plus y and an x plus y. So what I'm going to do is I'm going to write the x plus y outside, keeping the brackets, and then I'm going to open another set of brackets. Oh, interesting, he says. Let me just move this down a bit to give myself some working out space. Right, so what do we do now? Well, anything that we move outside the brackets has to then divide. So I'm now going to divide this by brackets x plus y, and I'm going to divide this by brackets x plus y. Well, we know from basic maths that when there is something on the top of a set of a fraction and something on the bottom of the fraction that are exactly the same, so long as all of the tops is multiplied and all of the bottoms are multiplied, we can actually cancel those out. So that x plus y there and that x plus y there becomes 1 and 1. That x plus y there and that x plus y there cancels out. So if we now look at what we've got left, we've got 3 times 1 on the top. And what do we got here? We got plus x times 1. So plus x, and there we go. We have now just factorized. Let's move this somewhere else out of the way so we can have a go at another one. Let's look at the next one down then. What do we got here? We got 7 minus 2x minus x, 7 minus 2x. In brackets, my mind is already going, hold on a moment, they are exactly the same. But whoops, hold on, there's nothing in front of my bracket there. Oh, there is. Because what is the one most important number that is not there? What is the one number we can miss out? What is the one number we can miss out? Well, it is basically 1. So I'm going to write a 1 there just so the question doesn't trick me. Right, well, again, how many terms do I have? Well, a term is something generally separated by a plus or a minus. So there's one term. There is another term. Do they share anything? They do. They share this 7 minus 2x. All right, so I'm going to write in the brackets 7 minus 2x, close the brackets, open a set of brackets, because when I'm factorizing, I'm writing things in a set of brackets. Okay, so can I take anything else outside my brackets? Well, let's just check. There's a 1 there, and there's an x there. I can't factorize anything out of there other than the 1, and I'm not going to write the 1 in this situation. Right, so let's divide. I'm going to divide this by 7 minus 2x. I'm going to divide that term by 7 minus 2x. Hold on a moment. What do we notice? Well, that 7 minus 2x and that 7 minus 2x cancel. 7 minus 2x and 7 minus 2x cancel. And again, when I say cancel, they become 1 on 1, because anything divided by itself is 1. And that comes in handy a little bit later on. So let's see what we got left on the top. We got 1 times 1 on the top. So I put 1 there. We got minus x times 1 on the top there. Minus x. And again, I have factorize. And again, I will leave the next two examples for you to have a go at. But fingers crossed you'll notice that that's got an a plus b, and that's got an a plus b there. That's got a 4x plus 3, and there is a 4x plus 3. The trick to this question is there should really be a 1 in front of there, and it's always useful to write it in. And you should be able to go on and do it. But I want to go back and just see whether you've seen a bit of a shortcut to this. Because if we go back to our first question here, what do we notice was in the brackets? Well, the x plus y, yep. What was outside the first bracket? Well, it was a 3. And what ended up here? It was a 3. And what was in front of the second bracket? It was a plus x. And what do we notice ended up in the second bracket? Jeez, I've just shown you a shortcut. Probably a really useful shortcut. Let's just check. What was in front of this first bracket here? It was a 1. What ended up here? It was a 1. What was in front of the second bracket? A minus x. The second bracket at minus x. We can now do those next two questions really quickly, but I'm actually going to leave it to you. Now, the problem with mathematics is we can throw curveballs, and suddenly we start putting in all sorts of strange questions here that you're like, well, hold on a moment, that's nothing to do. The previous questions were just practicing the skill, yeah? Now you got to actually use the math somewhere. So, for example, find the perimeter of the following shape and factorize the expression. Well, okay, first thing I'm going to do is I know that the perimeter is all the way around the edge, and I tend to start and I go around and I'm going to add that length and that length and that length and that length. Have I got all my lengths? Yeah. Well, they've given me 2x and 4. I know that's got to be 2x and that's got to be 4. So in which case, if I work my way around, I'm going to do 2x plus 4 plus 2x plus 4. Now again, I know lots of people do this in lots of ways. 2x plus 4 plus 2x plus 4. I know some people will double this straight away and go 4x and double that and give it 8. But I don't know. I do it so that everyone understands this. So now we're going to simplify. I've got 2x plus 2x. I'm collecting my like terms, which is 4x. I've got plus 4 plus another 4, which is plus 8. Now, lots of people would leave that as their answer, but the question was quite clear here. It said, write the perimeter and then factorize the expression. What does it mean to factorize? Move the highest common denominator out. We've just been practicing that. So let's look at my two terms. I've got 4x and 8. Let's look at my numbers first. 4 and 8. What's my highest common factor of 4 and 8? It's got to be 2. All right, so let's see now. What would happen if I do 4x? Oh, we didn't do my letters. Are their letters the same? Nope. Right, so 2 times what gives me 4x? Well, hold on a moment. Now I'm doing it a different way. That's okay. 2 times 2x must give me 4x. Or, if I wanted to, 4x divided by 2 would give me the 2x. Right, let's see what we're doing now. 2 times what gives me plus 8? Oh, positive 4. And lo and behold, ka-ching, I have factorized it. Now, some people actually will turn around and say, yeah, but I could have done that straight away. I could have actually just done the 2x plus 4 and double it, because that's what you do. And absolutely. So p is equal to 2 lots of 2x plus 4. You could have gone straight to that answer and it all would have been factorized. But I wanted to slow it down and show how this works for more complicated questions. What about this? Harder questions. It doesn't matter how many terms we have. If they have a common factor, we can move it outside of a set of brackets. Now, all the ones we've dealt with so far have had 2 terms, haven't they? These have got 3. 3a squared plus 9a plus 12. Now, later on in the course, we're going to deal with these type of things. But let's see what we've got. Is there any number that is common to 3, 9, or 12? Well, I think it's probably 3. So I'm going to write 3. Are there letters in every single term? Nope. We've got an a squared and a, and that doesn't. So I can't move any of the letters out. I'm just going to deal with the numbers. Right. So 3 times what gives me 3a squared? Well, it would have to be a squared. 3 times what gives me plus 9a? That would have to be plus 3a. And 3 times what would give me positive 12? And that would give me positive 4. Ka-ching! What about the next one? We've got x squared minus 2xy plus x squared y. Are there any numbers? Well, that's a 1, minus 2, and 1. So other than 1, and there's no point doing that. So let's look at the letters. I've got x times x there. I've got x times y there. And I've got an xy. So what's the most I can take out? And lots of people go, oh, it's x squared. Well, it isn't, because this one here only has 1x to take out. So I'm actually just going to take out 1x. And again, x times what gives me x squared? We know that x times x gives me x squared. X times what gives me minus 2xy? Well, if I get rid of that x, I've got minus 2y left, so it must be minus 2y. X times what gives me x squared y? Well, x times x gives me the x squared, and the y is just there on the end. And ka-ching. So those three terms are equally able to factorize. You've just got to find something that's common or highest common factor for each of those terms. And there we go. Believe it or not, that is the end of this video. Thank you very much. I know it's been quite long, about 24 minutes. Whew, that's very long, but hopefully 24 minutes of useful stuff. It becomes massively important a little bit later on. If you can, do me a favor and subscribe to my YouTube channel. Again, it just lets me know that you're watching. Head over to Maths Guru and sign up if that is useful. The Year 9 course is being populated as I speak, so hopefully it will be useful, and there are more videos coming. So hopefully I'll see you in one of those. If not, you take care, and please stay safe.